So we're back to this Carnival board, and when we left off, it had no signal. I'm sorry, it had signal, had nothing on the video. And while between this last episode and this one, I actually went down a wild goose chase, running down all the way back in the circuit, trying to track down a problem that actually wasn't there. And then I realized that I actually forgot on one of the first chips, actually the first chip that feeds the color lines, I didn't actually check the input. Or one of the inputs. I checked all the other inputs, and some of these were dead. But then I realized when I was testing it, I had the CPU in, so some of these inputs would be dead because the CPU is not feeding it. But this input here, number 1, on U67, which is right here, was dead, as you can see on the oscilloscope. So that's actually fed by this chip right here, U78, and all the inputs to U78 are fine. So I pulled that out, and I already did that obviously because I already tested this one. Put it in my chip tester. Error. So let's put in a new, that's a 166. Put a new 166 and see what happens. Look at that. Now we have green. Now, oops, that's not the one I want. So you see I actually have a signal there. Now, in the meantime, I was actually trying to get this thing to boot, and before, when I was messing with it, my CPU just I started smelling the smell of burning plastic. And I didn't see anything coming from it for a while. I'm like, oh, that's the smell of burning plastic, I know that. And eventually my CPU started smoking. And I figured, oh, that's odd, I've never seen that happen before. Maybe this one just had a short, started smoking. So I pulled it out, put another one in, and I'm pressing down on it, and that CPU started smoking. Actually, I think I have it in the trash here. Yeah, you can see here, it started, you can barely see it, it actually burned the label. And I realized something that's not going to happen twice. There's no way. And what happened is, I realized that underneath here, there's this jumper wire, and they're on all these, say, Gremlin boards, but this one was done really badly. And I realized as I was pressing in it, it was over these sharp pins, and this is a line, I think this is plus or minus 5, and that was actually getting fed directly, unfortunately, into the CPU, and that has since burned out some other chips. So we get the Fluke out and test again, and things are not working here. Remember, we had tested this before and everything worked fine from the Fluke standpoint, from the memory and the ROM. So I put this under here, this piece of cardboard, so to protect it now. Glad I didn't have my Fluke on it when I was testing it like that. So we'll put the Fluke back on. And that's my Fluke angry because I think I need to rebuild the power supply. Alright, so we put the Fluke back on. And bus test, and look at this. I get this new error, which I've never shown you this error before, because it doesn't happen very often. Controller error, some numbers, 10110000 loop. And if we read the Fluke manual, that means that's control lines, CPU control lines. That means it can't drive them. And if we look that up in the CPU manual for the Fluke Z80 pod, and it's actually on the Z80 pod 2, that actually means that it can't drive the mem request line and the write or read line. So if we look at the schematics, we find that all pulls back. So that's probably, a chip probably got burned from when that power spike melted the CPU. And if we put the things back in, that's actually the first chip those lines hit after the CPU all have that in common. They all use the exact same chip, U24. Now, so we'll put our tester on U24. I had actually tested U24 before. I hadn't showed you in the video. I don't think I did. But I had checked it the other day when I was testing things. And it worked fine. But now, you see that? It does not work fine. So, hopefully, that's all that got blown out by the, hopefully that chip, you know, took a bullet for everybody else. And hopefully it didn't blow out any other chips. So we'll go ahead and replace that and see what happens when we replace that. So we replaced that chip, and now let's see what happens. As you can see, we have green screen, but Carnival is one of those games, when you test it on a switcher, it actually will not start correctly usually, because it gets its reset signal once. Well, it gets it reset from the coin counter and from a power-up when from the power supply, basically, when it hits a certain voltage, AC voltage, it triggers a signal on the board. That will never happen because of the switcher. So I just have a button that I press. There we go. So that fixed it.
So it ended up that one of the resistors between the last chip that has the color outputs for RGB, U67, and the actual connectors on the PCB board that go to the monitor, there's a resistor for each color, and one of them was bad. It was way out of spec. Now, interestingly enough, I had previously actually replaced another resistor when I got the board because I could see that it was physically burnt. And that was also on one of the color lines. So I don't know what happened there, but the resistors were bad. So replacing that, and that fixed the color problem.